Good evening, everyone.
Sir, I think you're on mute.
Good evening, everyone. Will you able to hear me? Students, will you able to hear me now? Yeah. So the last class we discussed about the parabola and some numericals related to parabola. So it's a part of the conic sections. Today we are going to look into concept of ellipse. Yeah, minute. Yeah, sorry students. Today we are going to discuss about the concept of ellipse. So it's another part of the conic section. So how we will define the ellipse? It's very simple, same as parabola. it is having a different condition. An ellipse is a locus of all points in a plane, the sum of whose distance is the sum of whose distance is constant. The sum of whose distance is constant from two fixed points in a plane. These two fixed points is known as focus or foci, the plural form of focus point. It's very simple. Suppose if I am taking a point here, locus of all the points, that means I'm taking a 2 points. These are the 2 points. So this is a P, this is a F1, this is F2. You have to collect all the points in such a way Pf1 plus Pf2 is equal to constant. Suppose if I am joining P to F1 and P to F2, you will get the 2 different lengths. And might be this distance is fixed. That means if I'm taking some other point, this point also should be, suppose P2 also should be equal, the sum of the P2 plus F2 must be equal to this much, same constant, P2 F2, this is P1 F1, P1 F2, P2 F2 plus P2 F1. Or if I'm taking some other point P3, the distance from P3 to F1, P3 to F2 must be same. So if I'm joining all the points, you will get a oval kind of shape is known as ellipse. Suppose if I'm taking, this is the 2 fixed points according to the definition. You take any point. Suppose if I'm taking a point P, this is F1, F2. The sum of the distance from P to F1 plus P to F2 must be equal to anywhere. Suppose if I'm taking some other point Q, Q1 plus Q2, some other point R, RF1 plus RF2. If these points, if we join, what are the shape we are getting? That is called an ellipse. Plane geometry point of view, we are going to discuss the ellipse like this. Even practically also, we can draw the ellipse very easily. You can take 2 pins in a pin board. You can fix here. And you can take a thread. Suppose if the distance between these 2 pins is some 10 centimeter. And I'm taking a thread of some 14 centimeter. And this thread will be not tightened. It will be loose like this. And you take a pin, a pencil, and you try to draw, you try to collect all the points which is having the same distance like this. So like that, you can able to draw the ellipse also. I will show you if you are having any YouTube videos based on this, then it will be easy. You can able to try at home also. On your page also, you can try how to draw the ellipse easily.
உங்களை சேஃபா வச்சுக்கிறதுக்கு டென்ஷன் ஆவறீங்களா? Urban Company Home Disinfection பேருங்க. இப்பவே புக் பண்ணுங்க. So this is the string method. Fine.
I will share the screen. This is one of the easiest method we will use to draw the ellipse, where it will show the from two fixed point the distance is fixed. If you are unable to, you are not clear with the video, please let me know, guys.
An ellipse with a major and a minor axis. So first step is we're going to take the major axis, which is 10 inches, and cut it in half, which would be 5. So then we're going to take a point on the minor here and intersect those 5 inches that we found on that part right there. And we're going to do the same on this side. Again, we came down from this point and intersected 5 inches here and here. So then on those points, we're going to put a nail on each point and then put a point on this top piece too. And then tie string around it nice and tight. Take this one out and we are ready to draw our ellipse. Oh, that knot got me. So yeah, I hope that helps.
Look into this video, the length of the thread is fixed. Whatever the point you were taking, that from the nails to the any point on this drawing is always fixed. The sum of the distances from the both the nails is always fixed. This is a definition of the ellipse from the plane geometry. With the help of this definition only, we are going to derive the equation of the ellipse. Is it clear, students? What is the ellipse in plane geometry point of view? In conic sections point of view, if we cut the plane in a particular angle, that is a different. But here we are going to remember the definition of the ellipse like this. Is it clear? Shall I move to the derivation of the how to calculate the equation and different parts of the ellipse, students?
Yes, sir.
Yeah. See, these two fixed points are called foci or focus, plural form of the focus. These are the, like in ellipse, in parabola we are having focus. Like that, these two fixed points are known as foci, or it's a plural form of focus. So if I'm taking an ellipse, what are the different parts of the ellipse? As of now, we know the points is any point on the ellipse, the collection of all the points, which is equidistant from two fixed points. These are the two fixed points I'm calling as F1 and F2 called foci. The line joining of these two fixed points is called axis of the ellipse. There are two axes here. One is major axis and minor axis. One is major axis, another one is minor axis. Usually the line which is joining both the focus is known as major axis. And line vertical to at the midpoint of both the focus, and this is called minor axis. Length of the minor axis from here to here. Suppose here AB is called major axis and the distance AB is known as length of the major axis, and CD is known as minor axis. Here F1 and F2 is known as focus, and where O is called center of the ellipse, and A comma B are known as vertex of the ellipse. Vertex. A is also vertex of the ellipse. The distance between center and focus is known as focal length of the ellipse. C. I'm taking this constant is C. If I'm taking this distance is A, and This distance is B. And from the center, if I'm taking this ellipses on the origin, O to F1 and O to F2, the distance is C. This data is useful to locate the points of A, B, C, D, and as well as F1, F2. So from here, it will be easy to calculate it will be easy to express the expression of the or equation of the ellipse if the major axis is x-axis and minor axis is y-axis and origin is as the center. So first, a relation between semi-major axis and semi-minor axis. Semi-major axis is known as OA or OB is known as semi-major axis. OA or OB is known as semi-major axis. When it comes to semi-minor axis, OC or OD is known as semi-minor axis. So what is the relation between these two? It will be very easy to express. In terms of focal length, we are going to discuss the relation between these two. So according to the definition, if I am taking any point on the ellipse, the distance from that point to F1 plus F2 always remains same. If I am taking a point P at one end of the major axis, I am taking A. At one end of major axis. If I'm taking the point P at B, assume I'm taking a point P at here. This is my point P. According to the definition of the ellipse, F1P plus F2P should be constant, which is equal to F1O plus OP plus F2P. Anyone having any confusion in this equation? To bring the relation between minor axis and major axis, we are using this one. From here, F1P is equal to F1O plus OP, which is equal to C plus A. From here, we can write F1P plus F2P is equal to F1P is equal to how much? C plus A. F2P is total distance minus C. A minus C, C cancel, it is 2A. Same as if I'm doing for the, if I'm taking another point Q here, if I'm applying the same principle, QF1 plus QF2 must be same. That is the definition of the ellipse is equal to B square plus C square under the root plus B square plus C square. Because this distance is B, this is the C, this is C, this is B. I got B square plus C square. So according to the definition, Q is a point on the ellipse, P is a point on the ellipse. So any point, the distance between any point to the two fixed points, sum of the distances between the point to the fixed points must be same. That is F1P plus F2P. F2P is equal to F1Q plus F2Q. So F1P plus F2P is 2A. F1Q plus F2Q is 2 times root of B square plus C square. So 2 cancel. I can write B square plus C square is equal to A square. So this is A square is equal to B square plus C square. This is a relation between semi-major axis to semi-minor axis. Or I can write C is equal to root of A square minus B square. Is it clear, students?
Yes, sir.
Yes, sir.
Special case. Circle is a particular case of ellipse. How we can discuss? A circle is a particular case of ellipse. How we can discuss this one?
Sir, if A equals C.
Super. A is equal to C or A is equal to B? If A
Sir,
is
both,
equal to
sir.
B, if A is equal to B, what will happen? C will become 0. What is that meaning? If C is B, 0 means what? Your F1 and F2 should lies and coincide with the center of the ellipse. So where your major axis is also equal to A and minor axis is also equal to A. That means if I am saying A is equal to B, this will happen. Where C is equal to 0 according to the relation C is equal to root of A square minus B square, and it is 0, and 0 means what? F1, F2, O. This distance is 0. So F1, O, F2 is lying on the single point that is known as center of the ellipse. So like this we can discuss the if length of the major axis is equal to length of the minor axis, we can say that ellipse is known as circle. Same as when we can say ellipse will form a straight line. If I'm taking C is equal to A, when the C is equal to A, if B is equal to 0, if the length of minor axis is 0, the length of minor axis is 0, then I can say C is equal to A. So you will get this is only the simple line you will get. F1 origin, F2, sorry. This is F1, this is F2. If I am taking this point, Pf1 plus Pf2 is always equal to A, this length. If I am taking here also Pf1 plus Pf2, Qf1 plus Qf2, OF1 plus OF2, it is always remains 2A. So in this case, it's a straight line. In this case, it is a straight line. Is it clear, students?
Sir, it should be a line segment, right?
It's a line segment, sorry, not a straight line. It's a line segment. It's a line segment. Yeah. Next one is eccentricity. It's a little important when you move to the higher studies, particularly mechanical and designing courses. Because we are having the many methods to draw the circle. In engineering geometry, engineering drawing, they will start the course with the drawing the parabola, ellipse and hyperbola only. There they will give the data maximum focal length or ellipse or major axis and minor axis. That's it. The ratio between the distance from the center of the ellipse, the distance between the center of the ellipse to one of the foci and to one of the vertex. One of the vertex of the ellipse is known as eccentricity of ellipse. Usually the small e. Small e is equal to C by A. From the definition, how we can say? This is an ellipse. These are the major axis, minor axis, F1, F2. Ratio between the distance, this is a ratio between the distance between the center of the ellipse to, from the center of the ellipse to one of the foci to one of the vertex. So if I'm taking from the center to focus is C and vertex is A. So in this is will give the eccentricity. Is it clear? What is eccentricity, Sim? Students?
Yes, sir.
Yeah, now standard equation. This is only important in scope of the examination. Standard equation of ellipse. So standard equation means representing in the semi major axis, length of the semi major axis and semi minor axis. That is only the data I'm having. I don't have any other data. And center is origin. So in this case, what is the?
Sir,
Yes.
is there a maximum value of E?
Sorry?
Is there a maximum value of eccentricity?
Yes. See, what is eccentricity? C by A, correct? C by A. That is the
Yes,
definition.
sir.
So C by A means what? What is the C is always less than A or greater than A?
Less than A. Less than or
Less
equal
than.
to A.
Less than or equal to A. Less than or equal to 1. So eccentricity is always less than or equal to 1 for ellipse. Or you can write A square is equal to B square plus C square. From here I can write C square is equal to A square minus B square under the root. So eccentricity is equal to A square minus B square by A square under the root. So 1 minus B square by A square. So always it is less than or equal to 1. If eccentricity is less than or equal to 1, it is an ellipse. It represents an ellipse. So what is the maximum value of eccentricity? 1 for ellipse. If it is 1, what is that case? But if it is ellipse,
Circle,
what is it?
sir.
It is a circle. Actually, I suppose you to discuss at the end. Anyway, in this doubt, you are clear. Yeah. So, you know, what are the dimensions? This will be minus A comma 0. This is A comma 0. This is 0 comma B. This is 0 comma minus B. From the previous definition, you know the focus. This is, if I'm taking focus is minus C comma 0, where C is a focal length and C comma 0. So how we can discuss? I'm taking a particular any point P here. So according to the definition, Pf1 plus Pf2 must be equal to 2a. Do you agree? I can take
Yes, sir.
Because if the point is any vertex, the point is your vertex. Suppose A is a point, AF1 plus AF2 is equal to 2A. From that, P is any other point, PF1 plus PF2 is 2A. What is the P value? If I am applying the distance formula, what I will get here, students? If I am applying the distance formula, what I will get? P is x comma y, F1 is c comma 0, F2 is minus c comma 0. If I am applying this, what I will get? X minus c whole square plus y square under the root plus x plus c whole square plus y minus 0 whole square under the root is equal to 2a. So please solve this one and let me know what is your answer. X minus c whole square plus y square under the root is equal to 2a minus x plus c whole square plus y square under the root square on both sides. Students, please solve this equation and let me know what is the simplest form of this equation. What is the final simplest form of the expression you are getting? I will get here x minus c whole square plus y square is equal to 4a square plus x plus c whole square plus y square minus 2 into 2a into root of x plus c whole square plus y square. So if I am expanding, what I will get? X square plus c square minus 2xc plus y square is equal to 4a square plus x square plus c square plus 2xc plus y square minus 4a into root of x plus c whole square plus y square. So x square plus c square plus y square, x square plus c square plus y square. If I'm taking root term on one side, I will get like this. This will become minus 4xc minus 4a square is equal to minus 4a root of x plus c whole square plus y square. So 4 cancel. If I'm dividing with a on both sides, I will get like this. Minus c by ax minus a is equal to x plus c whole square plus y square under the root. Now I am squaring on both sides. I will get a plus cx by a whole square is equal to x plus c whole square plus y square. On simplifying, what I will get? This is a square plus c square x square by a square plus 2cx. 2a into cx by a, 2cx will be equal to x plus c whole square plus y square. On expanding, this will be x square plus c square plus 2cx plus y square. 2cx and 2cx is cancelled. So what is the final expression you are getting, students? X square plus y square is equal to a square plus c square x square by a square minus c square. We can bring into normal form, square minus c square. X square into
Sir, we can take LCM
plus y
LCM,
square
sir,
is
for
equal
x.
to a square minus c square. I can write like this. Students, from here if I am taking else, x square is equal to a square minus c square by a square plus y square is equal to a square minus c square. We know a square is equal to b square plus c square. From here, c square is equal to a square minus c square is equal to b square. If I am substituting this expression here, I will get like this. X square b square by a square plus y square is equal to b square. If I am taking b square this side, x square by a square plus y square by b square is equal to 1 is the standard equation of the ellipse. With a is the semi-major axis length and b is the semi-minor axis length. If a is greater than b, where a semi-major axis is x-axis, semi-minor axis is y-axis. Hope you are clear what I am trying to say. Is it clear?
Sir, can you wait 1 minute?
Yeah, please.
Okay, sir.
Suppose there are two possibilities which will satisfy the definition. Another possibility is where, like this, your x-axis is as the minor axis and y-axis is as the major axis. For understanding purpose, this point I am taking as 0, a, 0, minus a instead of taking b. Then you will get the same expression. You will get b, 0 minus b, 0. In this case also you will get the equation is x square by what I will get. According to the previous discussion, x square plus b square plus
y square upon a square.
Y square upon a square is equal to 1. Where here a is greater than b. The same thing. Only the thing is if y denominator is greater than x denominator, then your axis, major axis, minor axis will switch. That is only the difference. You have to keep it in mind, this one point to going before going to the numericals. But when it comes to anywhere, if the origin is not at the axis, if the some complete, if this is my coordinate system, suppose my ellipse is like this, or my ellipse is like this. Here, the discussion is a little bit different. I already told you, this is not scope of the syllabus. We won't discuss that. We will see at the end if time permits. Yeah. Next one is lattice rectum. Same as the definition of how we discussed. Suppose if I am having an ellipse, a line drawn perpendicular to the axis and passing through the focus and where it is meeting at ellipse. Suppose it is F1, F2. If I am taking a line and it is meeting at PQ and RS, the length of the PQ and RS is known as length of the lattice rectum. In this case, if it is my x-axis, this is my y-axis, the equation of this ellipse is x square by a square plus y square by b square. You know what is the meaning of a and b. From this, you can able to calculate the c value. the C value is nothing but A square minus B square. So, or with the help of the eccentricity also you can able to calculate. Now, the lattice rectum of an ellipse is the line segment passing through the any one focus and perpendicular to the major axis. And where it is intersecting the ellipse, the distance between the two intersection points is known as length of the lattice rectum. How we can calculate the length of the lattice rectum here? Anyone? With the help of your basic algebra, how we can calculate? Suppose this is my equation of the ellipse.
Point Q is C comma Y.
Yeah, point Q. This distance is C, and this is any point x comma y. So Q can be written as C comma y. And if Q is a point on the ellipse, I'm going to substitute here. Yes, please carry on.
Sir, then we can use the Pythagoras theorem, sir. We can join QF2.
QF2.
Yes, sir. So
QF1.
we know that QF1 plus QF2 is 2A.
QF1 plus QF2 is 2A. Super. Next. Q is C comma Y. And F is minus C comma 0, C comma 0. Next.
Sir,
this is C comma Y.
Sir, here we know that since QF1 plus QF2 equals 2A, so QF2 becomes 2A minus QF1.
QF2 is equal to 2A minus QF1. Next.
Yes, sir. So F1, F2 is nothing but 2C.
F1, F2, yeah, F1, F2 is 2C. Correct. Next.
Sir, and then using distance formula, we can find the distance between
this is Y,
and
this whole distance is 2C. Correct?
Yes, sir. So Y square plus 2C square equals 2A minus QF1 the whole square.
Y square plus 4C square is equal to 2A minus QF1.
So the whole square, sir. The whole square.
I'm taking square. Yeah, this is also square. Next. How you will solve from here?
Sir, QF1 is nothing but Y.
So Y square plus 4C square is equal to 2A plus 2A minus Y whole square.
Yes, sir.
Right?
So,
yeah, next.
Sir, Y square plus 4C square equals 4A square plus Y square minus
Y square plus 4C square is
4A,
equal
right?
4A square plus 4 square Y square
minus 4AY.
Y square cancel. 4 cancel.
4 cancel, sir. So Y equals, we get.
So AY is equal to A square minus C square. Y is equal to A square minus C square is how much? A square minus C square is nothing but B square only now.
Yes, sir.
So Y is equal to?
Sir, shouldn't it be 2B square by A somehow?
Yeah, that's all I'm going to give now. Y is equal to B square by A. This is a half of the lattice rectum.
Oh, yes, sir. Yes, sir. Sorry, got it.
F1Q is equal to half of the lattice rectum, half of the length of the lattice rectum.
Yes, sir.
So it is B square by A. So length of the lattice rectum is
2B square by A.
So basic geometry is enough. With the help of the eccentricity formula also you can able to discuss. By identifying the points also you can able to discuss the same derivation. There are many methods. So shall we move some numericals? With the help of this. Very simple numericals will lost from both point of view. Openly, I am saying from the conic section, this is an introduction to your BSc. If you are taking the pure allied sciences, pure math and all, in first year of BSc math, in geometry, they will start with the conic sections in 3D. In 3D, how we can write the equations and generations and calculus related, they will continue. But in +2 level, it's very basic level. So find the coordinates of foci, the vertices, length of major axis, and minor axis. Eccentricity and the lattice rectum. And the lattice rectum, length of the lattice rectum. X square by 25 plus y square by 9 is equal to 1. First, write into standard format. X square by 5 square plus y square by 3 square is equal to 1. A is greater than B here. That means X is. So A is equal to 5, B is equal to 3, and it is looking like this. This is 10, this is 6. So straight away I am writing, you can define your own. Focal length will be equal to square root of a square minus b square, that is 5 square 25 minus 9, which is equal to 4. Now I got ABC values. It will be easy to calculate anything. If I am talking center, origin, by seeing the equation, vertices plus or minus a comma 0, that is plus or minus 5 comma 0. OC plus or minus c comma 0, that is nothing but plus or minus 4 comma 0, because two focus, two vertices. Anything we missing? Length of the major axis. (2a), which is equal to 10. Length of the minor axis, which is equal to 2b, nothing but 6 units.
Sir, LLR.
Length of the lattice rectum is 2b square by a, correct? 2 into 9 by 5. 18 by 5. Anything? Is it clear? And final,
yes,
eccentricity we missing. What is the eccentricity formula? C by A, where C is 4, A is 5. So like this, you are going to discuss the most of the numericals like this. Might be little bit extension is they may ask the equation of the lattice rectum or equation of the particular line passing through it. Next question. Rana, same way, find out all the parts of the ellipse, which is equation is 9x square plus 4y square is equal to 36. Don't panic, just divide the whole thing with 36. You will get into standard form. X square by 4 plus y square by 9 is equal to 1. It is looking like x square by b square plus y square by a square is equal to 1. Here also the same way, but only the thing is draw the diagram where your major axis is y-axis and minor axis is x-axis. So based on this, you have to discuss center, vertices, foci, length of the lattice rectum, semi-major axis, semi-minor axis. Anyone can give? We'll wind up the session. Next class, we will discuss the exercise.
Sir, center is 0, 0. Vertices is plus or minus 3, 0.
Plus or minus 3, 0 or 0, plus or minus 3?
0, plus or minus 3, sir. Sorry,
yes.
Sir. And focus is 0, plus or minus 5. Root 5.
So what is the C value here? Same way. A square minus B square under the root. 9 minus 4 under the root. It is root 5. Correct? So what is the focus? 0, plus or minus root 5.
Yes, sir.
Length of the lattice rectum. Formulas won't change.
8 upon 3, sir.
B square by 2B square by A, which is nothing but 2 into 4 by 3, 8 by 3. So major axis is 9, not 9. Semi-major axis is 3. Length of the semi-major axis is 3, or it is y-axis. Semi-minor axis is 2, it is x-axis. And eccentricity is how much? C by A, nothing but root 5 by 3. Like this, we can discuss the different parts and different coordinates related to the ellipse. This is only the major scope of the topic from the ellipse point of view. If you see the questions, they may ask the different points and they will ask you to write, they will give the equation of the ellipse and they will ask you to write all these points, or they will give any data and they will ask you to construct the equation of the ellipse. It is easier than this. What I observed from the previous year's question papers, these kind of questions they gave for essay marks. And 1 mark and 2 mark, they will give form the equation of the ellipse. So we'll go with numericals in the next class. There are 20 numericals. We can wind up all the numericals very easily because 1 to 9 is all are like this only. They are giving 9 equations. They are asking us to do the center, find the coordinates of the foci, vertices, length of the lattice rectum, center, and eccentricity. These things only. So 1 question or 2 questions or 3 questions, the same method. Nana, Anna. Is it clear, students? And the rest of the thing is they may give vertices and foci. Some data they will give. They will ask us to what is the equation of the ellipse which is having the vertex and foci. They will give both the vertices and they will give both the foci. So these kind of questions we will discuss. And if the time permits, in next class we will discuss the equation of hyperbola also. I think hyperbola is there in the syllabus or eliminated for this year.
There,
students, is there now? Yeah, we'll discuss the hyperbola. Same way, condition for hyperbola, different parts of the hyperbola, lattice rectum, eccentricity of the hyperbola, and some basic questions. And that's the end of this topic. Yeah, we'll meet in next class. Bye, everyone.
Thank you, sir.